In this video, we will see what is Adaboost. Alright, here now let us take a data set having a features called F1, F2, F3, F4, and we have an output here. Okay, now here we have an input, here we have some input. Okay, we have something like this. Now our output can be yes or no based on the classification problem, right? Now here, as we have already discussed in our boosting technique, it is a kind of sequence. Okay, here we are trying to take a feature 1 with the help of feature 1 or 2 with the help of information gain and entropy. The help of information gain and entropy. So based on this, we'll select the features here. But here we are trying to split only to one level, and we'll take the next feature and again we'll split it to one level, and we take feature 3 based on the information gain and entropy will split to one level, and these are called stumps. Basically these are called as stumps, right? And these are all weak learners. These are all weak learners. Suppose we have a wrong record in the feature f1. In that case, it will just send this wrong record to the feature 2 with some set of records again. And here, if we find some wrong records, again these wrong records will be sent to the next feature F3 again with some set of records. And finally, we'll just look at the output. Majority whatever we get, we'll select that as our answer. Now we'll also see here the first thing is like here we would like to calculate the total error. How we are going to calculate that? Let's see. We are going to calculate the total error. We need to find out the wrong record basically. Suppose if I have so we have a data set here. Suppose in this case if I find a wrong data set here in this, let's say for a feature f1 we have a wrong data set. Now here we are trying to put up some weights here. We're trying to put up some weights here. See, we have 1, 2, 3, 4, 5, 7 records we have. So we are trying to divide this in terms of equal weights. So here, if we divide equal weights, we'll get 1 by 7, 1 by 7, 1 by 7. And overall in combine, we need to get here 1. If we combine all these weights, we need to get a value 1 here. We need to find the total error here. Okay, total error here will be 1 by 7, and this is our total error, right? This is our total error, and the next step we need to find is a performance of stump. So through this performance stamp we can calculate, we have a formula to calculate half log to the base e 1 minus total error divides by total error. So we now have a formula here, log e 1 minus 1 by 7 and 1 by 7, where we'll have 0.0895 as 0.895 as our value. Now here we would like to just see what where we have the correct records and where we don't have the correct record. Suppose we already said that we don't have a correct record for this row. Okay, now in this case we are trying to find a new sample weight here. We're trying to find a new sample weight here. New sample weight. Now here we are trying to calculate that new sample weight with the formula. Let's say we have for correct records, we calculate with weight multiplied by e to the power of minus ps. Okay. Now here for our correct records, these are all our correct records, right? This, except this, we all have correct record. Now for the correct record, we have a weight called 1 by 7. Okay. Now e to the power of, we have got the performance of stamp, right? Now we have got that, we need to just put up e to the power of minus 0.895. This is performance of stamp, which is equal to 0.05. Now similarly for incorrect records, we have a weight multiplied by e to the power of plus ps, which is equal to 1 by 7 multiplied by e to the power of plus 0.0895, okay, which is equal to 0.349. Now we have here our new sample weights, which is equal to 0.05, 0.05, 0.05, and here we have our weight increased for wrong record, which is 0.349. Here again 0.05, 0.05, 0.05. Now, let us just make a table here. Let us make a table here with our new weight. We have got the new weight. Okay. Now, what we have here is 0.05, 0.05, 0.05, and here we have 0.349, 0.05, 0.05, and 0.05. These are our new weights. Now we are trying to have, because when we sum up, this is not going to get a 1 here, definitely for sure. So we are trying to normalize these weights by using, now we'll just separate it with a separate column. Let's say we have a new column, normalized weight. Okay. Here let me just take a total from here, which I will have point 649. Now I will just divide 0.05 with 0.649, so I'll get something around 0.007 some change. So I'll just update all those records. Okay, 0.07. Now here I will have 0.537 some change. Let me just update all these records. Yes. Now when I combine all these values, I'll just get a value approximately equal to 1. Now in the next step, we'll try to create a buckets here. I'll try to create a buckets. Now here for the first row, we'll have 0 to, it's just a cumulative sum. Now we'll add 0.07 to this value, we'll have 0.07. Now we will have, sorry, it'll be 0.14. We are now putting it as a cumulative value on the right one. Now we have 0.14 to 0. Something around 21, right? 0.21, and we have here 0.21 plus 0.537, which will be approximately 0.747. Again we have here 0.747, and so on. We are going to calculate. Now here what we are trying to do actually, see, we have we have a root node, and we also have the leaf nodes. Now we are trying to break it here. That's why we are calling it as stump. And one more thing, we are going to use here only decision tree models. All right. Now in this model, we have, uh, suppose here we have some wrong record here. So based on these buckets, we are trying to find what actually wrong record for this branch. And similarly, it'll go to the next model again. It will find, now here will it will identify the wrong records, and these wrong records will be sent to the next model. And also some of the data set from the table will be going to the second model, right? Now here we'll get around the output like maybe 0. No, we have already seen that, right? Like now we'll create a models like this. Now we'll create a models like this. Okay, all models like this. Now when we send our new test data set here, now it will check the wrong records from this model, and it will send that wrong records along with some data. It will send it to the model 2. Again here it will check and it will identify the wrong records, and then again it will send it to the next model, and so on. So for each model we will have an output, and we already told that this individual each model will be a weak learner. Now individually we'll have an output which is a discrete, which is a classifier, right? So we'll have an output either 0 or 1. Suppose we have got an output for this as 0, for this as 1, for this as 1, and for this as 1. So majority we are having 1 here. So our output will be our output will be 1 for this. Similarly, for regression problem, we may have some values here: 26, 23, 25, and 21. In this case, we are going to take the mean of these values and say that will be our output. That will be our output. Now here we have two more things I would like to discuss: black model versus black model versus white white box models. Generally, we have discussed so many algorithms till now. So linear regression we have discussed, okay, and random forest and decision tree. So we call linear regression as a white box model because visually we can see the change in values of theta 1 and theta naught, and also we can see the gradient descent algorithm, how the next step is moving further. But in random forest we are not able to see anything, so it's a very complicated maths behind random forest. A lot of decision tree models are involved inside this random forest, so this will be called as black box model. Now again, decision tree we can actually take out with a paper and pen, we can mark it simply, so we can actually see this decision tree how actually it branches up. So this will be our white box model. All right, this is about Adaboost in this video. I'll try to continue with some more algorithms in our next video. Thank you for watching.